kind of give you a background on how this online help session is going to go. It is set up to answer questions on the particular section that you were covering for that day that I'd asked, and this happens to be 2.4, right? So any of the questions off of 2.4 that you didn't understand when you went through the lesson, through the video that's up in Blackboard, stuff like that, need a little bit more clarification. It is not set up to reteach you. The lessons, the videos that I have up there is the lecture itself. This online help session is for you to be able to ask questions that you are uncertain about or have questions about. So that's the whole purpose of this, okay? So this is number 7 off of, what do we say, 2.4, right, guys? Or, yep, number 7, section 2.4. Okay, so you're adding complex numbers. Okay, remember complex numbers are in the form of a plus bi, right? Where a and b are real numbers, and the I portion of it makes it complex, right? The imaginary, and then there's the real. So when you go to add or subtract these, and it's only on the adding and subtracting, you will take, and for this particular thing, you have 4 plus 2i. And this is addition, so I don't have to worry about, and there's a positive 1, so if I distribute that, it just becomes this, right? If this was a negative 1, I would distribute it through, changing all the signs. At this point, it's basically, where are my real numbers? And then, where are my imaginary numbers? So my real is 4 and negative 4. So these two will give me a 0, right? Now I'm going, what'd you do? Yeah. So you'll do add and subtract, and then you'll start in with the multiplying. But that right there is going to be your telltale. And then here's your 2i and 4i gives me 6i. So when we do this, 0 plus 6i is just 6i. And does it have to be in a certain form? Yeah. It has to be in the form of a plus bi. Well, if the a is 0, then it is just, guess what, 6i. I would never put it in the form of this. I'd never go bi plus a. Okay, I'd never do that. All right. So that's you know, I'm not sure if it would mark it wrong. I'm probably about 85% sure that it probably would. But the mathematical community as a whole, our number system as a complex number system is set up in the terms of a plus bi. So that's why. So if you try to do it like that, it probably will mark it wrong. But try it and see. I mean, I haven't put them in this particular program, but with everything else I've looked at, I'm pretty sure it probably will. So, all right. So that's number 7, section 2.4. All right. Do y'all have? Let's do this. Any more out of that section? Mm-hmm. Ah, yes, yes, and yeah, and I hate it that there's only one particular example on this one, but let me make sure. Yeah, we're recording. Um, I will do a couple of these, okay? And I'll tell you how to do this and make it a lot easier for you. They're not that difficult after you understand the premises behind it. So first thing we have to understand is this: I to the first is nothing more than I. I squared is -1. I cubed is negative I, and I to the fourth is nothing more than 1, right? So here, this little thing we've got right here, this is the whole kind of key that we'll use, all right? So we need to express I to the 24th as one of these particular items right here. It needs to be one of these that I'm highlighting, okay? So in doing that, this is what you get. Um, we're going to use these powers to rewrite I to the 24. So it's kind of like a power to a power rule, right? Where you had like x to the a raised to the b, right? And that would give you x to the a times b. That's the power rule for exponents. So we're going to use that in order to help us, along with the information that's in the red box, to evaluate these i's to some kind of power. Okay, so I'm going to erase this real quick. Now, so what we're going to do is we're going to rewrite. This is kind of like a stamp. I'm going to go I to the fourth. That's the first thing I'm going to do. Now I'm going to put a parentheses around it. Okay, the reason I use I to the fourth is this. I to the fourth, guys, is equal to 1. Okay, so what we're going to end up doing is we're going to be raising a power of 1 to, or the number 1 to a power, some power. And if you know, 1 raised to any power is 1 period, because 1 times 1 times 1 times 1 times 1 is always 1. So the first thing that I do is go, okay, how many times will 4 go into 24? It goes into a 6. And when I put this 6 here, if you look at this, 4 times 6 is what? 24. So I've really used that power to a power rule to be able to expand it, and 2 to be able to double check it. So I to the fourth, that gives me I to the fourth raised to 6, that's 24, right? So really that is 1 raised to 6, which is just 1, right? So the answer is 1. All right. Now, that's a good question. So, are y'all good with this? Everybody, you've got this copied down. What I want to do is I'm going to turn around and we'll rework another one. Okay, so I to the 21st, right? So the first thing that we do is what? We always rewrite it as I to the what? Fourth, right? So how many times will 4 go into 21? Basically, 21 divided by 4 is what we're going to do in the calculator. And what that comes out to be is 5 point something, right? 21 divided by 4 on the calculator is 5.25, right? So we know that it will at least go 5 times. Y'all agree? Because 4 times 5 is 20. Now, the previous example showed it going into it evenly with a remainder of 0, right? So if it has a remainder of 0, then the answer is 1, because it's just 1 raised to any power, right? But if it's something that comes out as a decimal, meaning it's going to either have a remainder of 1, 2, or 3, right? Then that's what's going to drive our answer. So 4 times 5 is 20. So I got I to the first, because if I do this, this gives me 20, and I times I, 20 plus 1 gives me what? I to the 21, right? Okay, so this is nothing more than 1. Agree? I to the fourth is nothing more than 1. 1 raised to any power is what? Just 1. I to the first is who? I. So the answer is, guess what? I. Now let's work another one. Okay, let's do one I to the 47. Okay, so I'm going to hit pause, and I want you to evaluate I to the 47. Okay, go. Okay, y'all ready? So, what'd you get for an answer? Okay, so I to the fourth. Let's see. I agree. I to the fourth is my first thing. 47 divided by 4 is 11, right? 11 point something, right? You agree? Now, times, I because it didn't go into it evenly, then I know I've got some remainder. My remainder is either going to be a 1, 2, or what? 3. Here's my, let's see. So that's 44. So my remainder is what? 3. I cubed, right? So this is 1 times, what's I cubed? Negative I, which is what? There you go. To give you a little bit more. Normally, or traditionally, some teachers teach it in terms of rewriting it as I squared. Um, I don't, because see, I squared is -1, and it depends on if you have to look at it in terms of an odd power or even power that it's been raised to decide whether it's a negative or positive. I just go I to the fourth because I to the fourth is 1, and 1 raised to any power is just 1. So it's either going to have a remainder of 0, a remainder of 1, remainder of 2, remainder of 3. And this right here is what I'm talking about, remainder, okay? This stuff right here, that and that. These remainders of these problems are really the answer, because we're going to multiply them by 1, because that's what I to the fourth raised to any power is going to be. Okay? You want need another one, or are you good? Okay. All right. All right. So let's look at any more off of 2.4. Mm-hmm. Yeah. Okay. There's really not, but I can show you. I hate to sit. Well, there's really not. Um, so this is what do we say, number 15. So number 15 on 2.4. All right. So what we've got is a complex number in the denominator, and we can't have that, right? So what they want us to do is they want us to multiply top and bottom by its conjugate. Okay. It's the opposite. Uh, no. Um, well, it's the conjugate of the denominator, right? What you're creating is what's called a difference of squares. Okay. Yes. Yes. I'm sorry. Yes. It will always be the conjugate will always be the denominator if it's a binomial, right? Like this. Um, 5 plus 3i, the conjugate would be 5 minus 3i. And it's the second number or the second term that has its sign changed. And the reason it's for that is based off of the difference of squares in polynomial theory. When you have a difference of squares, you have no linear term, right? So what this does is when we multiply these, and I'm going to sit here, I normally do the first term times everything in the second. So what we'll do is we'll do it like this. So I take 5 times 5 minus 3i, and then I go plus 3i times 5 minus 3i. Okay. Y'all see how I take the first term times everything in the second, right? Parentheses. Kind of treat it like this. It's like FOIL, right? Really, this is FOIL. And then up top, we'll go 2 times 5 minus 3i minus 3i times 5 minus 3i. Okay, so what this does is it gives us a couple of things. 5 times 5 is 25. 5 times negative 3i is negative 15i. Positive 3i times these would give me positive 15i, and then this would give me negative 9i squared. So I want to take care of the denominator first. These two like terms all go to 0, right? Because they're additive inverses of one another. So those are going to drop. That's what the difference of squares is doing. That's what the 5 minus 3i multiplied to 5 plus 3i is going to do. It's going to get the I out of the denominator. That's the whole process of what we're trying to achieve. Now, that's going to leave us with 25. Now, this is negative 9. We said I squared was what? Negative 1. So this is really negative 9 times I squared. So I squared is negative 1. So negative 9 times negative 1 is plus 9, right? So 25 plus 9 is 34. Okay, so if you look at the denominator, when we got done with the denominator, we don't have any I left in it, do we? So we call that rationalizing the denominator, because remember, I is really the square root of negative 1, and you can't have a radical in the denominator. Now we can do the top, and that's going to give us 10 minus 6i. Don't forget this sign here with its middle term right there. And then that's going to give us a negative 15i plus 9i squared. Now, these become, that's negative 6i, negative 15i become negative 21i, right? And then this would be positive 9 times negative 1, which is negative 9. So we have 10 right here, 10 minus 9, which is 1, right? Minus 21i. Now, it should take it like that, or what they're probably going to want you to do is this. Split it. But make sure your fractions are reduced. Does that make sense? It's a lot of work just to get to us, to get that I out of that. But what I mean by a lot of work, it's a pattern, right? I know when I get done with the denominator, I should only have a single number, right? Nothing with I in it or anything like that, just a single number in my denominator. And when I get done with up top, I know I ought to have a number and something with a I. Should have a plus bi, right, at the most. So then I split my fraction 1 over 34 and minus 21i over 34. And if we're looking back at our answer, do you see how they've got the I right there already plugged in, right, guys? They've hard coded. Here's your fraction plus a fraction I. So when you do this, because they have that, you're going to go and put negative 21 over 34. Okay, at least that's the one that I've got to work, right? Okay, does that make a little bit more sense? Okay. Uh, have y'all had the opportunity to watch the video 424? Okay, because what I'm wanting y'all to do, and the whole purpose is this, is for y'all to, instead of doing 2 sections in one night and not seeing y'all again until Wednesday night, is to do a section every night. And kind of break it down. This is 2.4 has been modified, 2.5's not. I don't know if you saw the new notes up there for 2.4. Um, so um, well, I went through um, and well, they're going to have this on it. Let me show you what I'm talking about here. Um, yeah, let me do this. Go notes and then 2.4. Where did I do it? Oh, I'm in chapter 4. Chapter 4. I'm in 5 o'clock class. Okay. So 2.4 and 2.6 are modified, right? And I took the old ones down and then put the new ones up. And here's what I mean by modified. Um, I went through and problems like this right here that we're not going to cover, they say scratch, right? So they are essentially everything that you have, except for some things that are been marked out. Um, yeah, I think that's, yeah. So that's what I mean by modified. 2.4 and 2.6. And if you kind of look over here at these questions, right? I took out a couple of these questions. 5 and yes, but if you go to Blackboard, make sure that the section that you're looking at as far as the video, if it says the file says modified, then you might want to print it out again. Or if you've already got it printed out, open it up and mark through the ones that I say scratch. Okay, because that way when you get to that part on the video, you can just you don't have to worry about that content. Does that make sense? Okay. All right. Anything else that got you? Okay. Okay. Have y'all had the opportunity? I'm gonna ask you this. You really got to answer anything. I'm gonna pause the video.